Hello everyone, I hope you all are well and making progress in life. Here is Priyanshu and welcome to the Infinity Mind. So today I will be solving the problem permutation sequence. So the problem statement says that we are given n and k and we have to return the kth permutation sequence of all the possible permutations of n sorted in a non-decreasing order. So we can see here the set, let's say the set will contain, we all know what is a permutation, a set where all the numbers are there from 1 to n, no matter they what's their order. So we all know if n is given, there are total n factorial unique permutations, and and we have to list them in sorted order, and we have to return the kth permutation sequence. So in the example 2, in the example 1 we are given n is equals to 3 and k is equals to 3. So if n is equals to 3 and k is equals to 3, so we know that if what is the first permutation, this is 1 2 3. What will be the second will be 1 3 2, and then what will be third will be starting from 2, and here the smallest one 2 1 3. So n is equals to 3. So if we write all the possible permutations, there will be total 6 possible permutations, because 3 factorial is 6. So now we have to return the third permutation if we sort all the permutations in sorted order. So in lexicographically sorted order. All right, so we get this answer 213. Now in the second example also we can see that n is equals to 4 and k is 9, k is equals to 9 is given, and if you take this if we write all the permutations and check the ninth sequence, it will come 2314. So if I explain it how we can solve this. So brute force approach which can come into my mind is that we try that we store all the possible permutations in a vector and then just sort it. So first of all I will take what the brute force I'm telling, n is given, k is given, and what I will do, I will just form all the possible permutations. So for creating all the possible permutations, this will take n factorial. Then I will store them in a vector. So storing them in a vector will take extra n time complexity, and then I will sort it. So we all know sorting takes x log x. So here if x is n factorial n, then sorting it will take x log x. All right, so this is very high time complexity, and now we cannot go with brute force approach, so we have to do something. So we all know we have to return the kth permutation sequence, and all the permutations will be in sorted order. So if I take this example, or example 1 only, if I take, so n is equals to 3 is given and k is equals to 3 is given. All right, now we all know that n is equals to 3 is given. So what is the first permutation? What is the first permutation? This will be, we all know we can write 1 2 and 3, and we have to return third. So 1 2 3 is given. Now we all know this is our, let's say, permutation. All right, now what will be my first one? If I try to write all the, this will be my first permutation, and what will be my last? My last permutation will be 3 2 1, just opposite. So we all know in the of all the combinations, some sequence will start from 1, some will start from 2, some will start from 3. So if we say that someone is starting from 1, we have 3 places and we have filled the first place with 1. Now we are left with 2 places, and here either we fill 2 or either we fill 3. So this will, how many possible permutations are there? Total number of possible permutations are 2 factorial. So this will be 2. And now permutations starting from 2, here either 1 can come or either 3 can come. Again 2 factorial, that is 2. Alright, now again if we fix the first one, that is 3. So either we can fill 2 or either we can fill 1. So again 2 factorial. Alright, so we want here the third permutation. Alright, so we all know, if we take the 0th based indexing, so we can say that this will be my 0th, 1 2 3 will be at my 0th index, and 3 2 1 will be at my what, 3 factorial. 3 factorial is what, 6. So if I am taking 0th 0 based indexing, so this will be at my 5th index. So if I fix 1 at the starting, there are total 2 possible combinations. So I know that all will be sorted. So starting from 1, if there are total 2 combinations, so they will be definitely starting from they will be at index 0 to what, 2 or 1, two combinations are there, so 0 to 1. And if I start from 2, again 2. So starting from 2 to 8th index and going up to 3rd index, again starting from 4th and going up to 5th index. Alright, so what I want 3rd permutation. So if these are arranged in a vector in a sorted order, what which permutation we want? Here we want kth permutation, but in 0 based indexing we want the 2th index element. So here we want 2th index element. This will be our answer. So this 2th index element will be our answer, whatever it is we want it. So from here, this observation, if I fix the starting ones, I will be left with 2 options. So I have written all these things. So I want to know where this, we want 2th index element, and from here the observation which I have understood, I will try to find here the 2th index element. So we can see that 2th index element is here. Alright, so the 2th index element block is here, and it is sure that it is starting from 2. It is starting from 2, but we don't know what will be the other 2 numbers, but we have now got what's the first number. So if I say that my result, if I say, let's say if I write result here, so if I write result here, let's say, so I know that I know that this there will be three digits, and I know that I have to find the second 2th index. So from here I will find where my 2th index is lying. So how can you know where my 2th index is lying? So this is easy. We are just given k is 3 here, and what we can do, we can just check whether this 2 is lying. So we know that total we know that every block has total two combinations, two. All right. So if we divide if we divide k minus 1 by 2, so what was k? K was 3, and if I divide this 2 by 2, this will give 1. So this 1 will tell me here that which I have to take. So if these are arranged in uh, let's say 0th based indexing, so here I will see that after dividing k minus 1 by 2, so why k minus 1 by 2? Because k was what? K was telling that which permutation I want, and I know that I have to find 2th permutation, 2th index permutation. So I have to find 2th index permutation, and elements are starting from 0 and going up to 5 index. All right, and I have to find 2th index permutation. So if I divide this 2th index 2th index by total, see, if there are three, let's say I'm taking the example here, 3 blocks, and one block size is 2, another block size is 2, another block size is 2, and they all are arranged in sorted order, and we have to find the 2th index, where if they see, if it is containing, if one block is containing 2 elements, 0 1, second block is containing 2 elements, 2 3, and next is containing 4 5, and I want to know where this 2 is lying. So can I just check it by dividing it by the size of blocks? So suppose I have to find 4. So if I divide this 4 by the total number of blocks, this will give 2. So if these are 0 based indexed elements, so this 2th block, I will know that 2th block is containing 4. If I want to find 2, I will divide 2 by 2, this will give 1. So I know that 2 is hiding in 1th block, and if I want to know where is 1, I will divide 1 by again 2. So I will be able to know, if any element I want to know, I will just divide it by the number of block, and I will get the index of that block. So this will give also 0. So I know that this is hiding in 0th element. So here I got to know that I have to I have my this after dividing by total factorial, which is was coming here, that is 2. So it is telling that 1. So the 1th element, the 1th, I mean the 1th block is containing the 2th index element. All right, so here we got the starting element, that is 2. So I will fill now the starting element by 2, and if I have to find that what will be these 2 elements, so we can simply say that here if we have to find in this block where was 2, at the 0th element or at the first element. So now if I have to find that what will be the position in the first block of 2, so if I have to find the position of 2, whether it is at the 0th position or the 1th position, so I can simply modulo 2 of which element I want. So if I want 2th element in the first block, I can modulo 2 and I will get the column number where it is saved. So it will give 0. So it is telling modulo 2 is coming 0, and we have now got that this will be at the 0th position. Similarly, if I have to find which row it is hiding, so I will just divide the index by the total number of columns which I have to every length of block, and if I have to find the column number, I will modulo 2. Alright, so simply I have found here that in the 1th block it is hiding. Our 2th index element is hiding in the 1th block, and 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 the 0th column, and at the 0th column. So now we can see our problem is reduced to I have stored 2 because the starting element is 2. So now I have to fill these 2 elements only. So if I have to fill these 2 digits only, so I can say that my n is 2, and here if these 2 elements are there, if I am at this block and I know that my first element is 2, and I know that I have to fill these 2, and so in this block which element I have to find? So in this block we know that we have to find here now k minus 1 modulo 2, as I told earlier that in this block I have to find the 0th element, because k minus 1 modulo 2 was coming 2 modulo 2, which is 0. So in this block I have to find the 0th element. So I will say that when n is equals to 2 and the array was what I have used 2, so from the permutation 1 comma 2 comma 3 I have used 2. Now I will delete this 2, and now I will be left with only 1 comma 3, and I have to fill these 1 comma 3 in such a way that I know that my first number will come 1 3, and my last will come 3 1. This will be my 0th and this will be my 1th. So I know that now I have to go and find here the k minus 1 modulo 2 element inside this block. So it means that I have to go and find the 0th element here. So this is now the similar question that we have just done here. Now I will apply the same algorithm here, that n is 2, k is 0, and permutation is now updated to this, and now I have to fill this 1 comma 3. So again either it will be starting with 1 or either it will be starting with 3. Now if it will be starting with 3, then I will be left with only one place, and here only 3 can come and here only 1 can come. So total possible ways will be just 1 factorial. So this will be 1, total possible ways will be only 1. Now I have to find the 0th element here. I have to find the 0th element here. Alright, so how will I know the 0th element is lying in this block or this block? So for that I will be dividing k by the size of every block. Size of every block is 1, so I will be dividing 0 by 1. This will give 0, and I will know that this is lying in the 0th block. So this was 0th block and this was first block, because indexing is 0 based. So now I will know that this will be lying in the 0th block, and the 0th block starting element is 1. So I can say that here the starting element will be 1. So I will update here also in the result that starting element is 1 now. And now in this 0th block, how will I know There are basically two blocks now, and I have got to know after dividing k by the size of the total blocks, that was 1. So I know that this is lying in the 0th block, but how will I know that where it is lying in the which position it is lying in the inside block? So for that I will do modulo 1, and this will tell me which position my 0th element is saved. So after doing 0 modulo 1, so 0 modulo 1 is 0. So now my problem is reduced to, my new permutation will be what? I have used 1 now. And my problem is reduced to permutation is only left 3, and I have to only fill this one digit now, and I have to fill this only one digit. And here we can see n is 1, and which element I have to find inside this block? I have to find only the 0th element inside this block, 0th position element. So now my problem is reduced to this. So now when n is equals to 1, I can say that there will be only one element left in the permutation array, and we can fill this place by only one way, that is using this 3 here. So I can simply push back this 3 in the result that was here, and then I can just return. Alright, because there is no need to check further, because if there is only one element left, there is only one possible way, so no need to apply algorithm anymore here, and we are good to go. And now we can see that our resultant array is filled now, and now we can say our answer is coming 213. So here also we can see our answer is 213. This is telling us the third permutation sequence. So now if I go and implement this problem, so first of all, what I said, that what I was doing, first of all I was storing a permutation array. So first of all I will create this permutation array. So for permutation array will be, how can I create the permutation array? I can use vector. Alright, so I'm creating vector. Now for writing for creating the permutation array, I will start from I is equals to 1, and I will just create this permutation array. Now this will be pushed back with I. Now my permutation array 1, 2, 3 is ready. Now what I want, now what I was doing, I was just checking whether is it where it is lying. So first of all, when I was filling, I was taking the first element, then second element as our first digit, then third element as our first digit. So how I was knowing that which element do I want? So I was dividing k by the size of every block. So in this case, what was the size of this block? So size of the block was here 2 factorial. Alright, so first of all I have to find out the size of the block, then I can move ahead. So for finding the size of the block, we know that for our first iteration, size of the block is 2 factorial. So here are 3 elements, and now I have to find the factorial of 2. So I will go and find the factorial of n minus 1. So how can we find the factorial of n minus 1? So I can just initialize factorial by 1, and I am running a for loop. So what I can do, I can every time iterate from I is equals to 1 to n minus 1, and then update my factorial. So if I is less than n, I will multiply factorial by what? I. So this will help me storing the size of the blocks. All right, so here the size of the block is 2. So this will give us the size of the block 2. Now I have to find which block our 2th index element is hiding. So I am seeing that 2th index element, so k was given 3, so I should reduce 2 also, because I am taking 0 based indexing. Now I was storing also uh, result also, and we have to store the result in a string. So I should create a resultant string as res. And now what we were doing, uh, first n is equals to 3. For n is equals to 3, I was finding where the 2th index element is hiding. So it was hiding at k minus 1, because k was 3. But when I have reduced k by 1, I don't need to do this k minus 1. So k by 2, k by block size block. All right, so here it will be hiding. So we all know that we have to do this every time. So either we can use a while loop, or we can do this recursively, or we can use a for loop, because we are running from n is equals to 3, then n is equals to 2, then n is equals to 1. So I can use a for loop instead. Starting from I is equals to, first I is equals to n, then it will go up to I is equals to 1 and move. All right, now every time I have to find which block it was, which row number I should say, 0th, 1 or 2nd, my permutation was hiding. So if I want to find the 2th index element, I will first of all I will find which index element to take. So let's say index will be what, k divided by factorial. All right, what I did earlier. Now this element k divided by 2 will give us what, 1. So I know that 1th block element will be our will be having our 2th index, our kth index element. So here the starting element is 2. So in the permutation array of 0, 1, 2, this 2, what I found that k divided by 2 is 1. So I will say that I will go at the permutation index and I will take this element, because it was telling that this block is giving us is storing the 2th index element, where the first digit is 2. So I will store this first digit. So first digit is what, permutation of index. All right, so this was storing at the first index. So here also at permutation it is storing at the first index. So I will take 2 here. So here it was storing at the first, here it is also storing at the first. So I will say that go and in my result push back the what, permutation of index. All right, and after pushing back 2, I can delete this 2 from here, so that after moving I can get just 1, 3. I have to delete this. So for deleting from the vector, I can just use erase function. So I'm using the erase function. So permutation dot erase, and I will pass here the iterator. This will be permutation dot begin plus idx. Now what I have to do, I was doing 2 things now. I was finding here in the block which what is the position. So this can come from modulo, k modulo the factorial, and then I can move ahead with a new problem where my permutation is new. my n is new and my k is new. Alright, so what I can do, I can and yes, I have to reduce the factorial also. I cannot find factorial again and again, so I can just say that if my I is greater than 1, then every time my factorial can be divided by I minus 1, because in the first case, when I was equal to n, that is 3, my factorial was coming 2, and then this factorial was 2 2 into 1, and then next time when n is equals to 2, my factorial for one digit was coming 1, so I have to drop this 2. So I can, what I can do, when I can divide, before moving ahead I can divide this factorial 2 into 1 by 2. And what will be 2? How can I find 2? This I is equals to 3, so I minus 1. So I will divide the factorial by 2, and yes, my new k, when it will go into next loop for next n, for next I, my k will be new, so k will be now modulo, k will be modulo of factorial. K will be, I will modulo k by the size. Alright, so I should write k before, because I will be updating factorial. Alright, so now we can see that our resultant string will fill, and this way we can store the resultant, and at last I have to just return the result. And if I run this and check, we haven't made any mistakes, so we have done some mistakes, so answer is coming empty in the case 1, and again empty. So okay, so now we can see here that our permutation array is an integer, it's storing an integer, but our resultant is a string. So we should, before pushing back, we should make sure that this is a character. All right, so we should write here 0. This will convert this integer into a character. So if I now run this, so it is passing, and now if I submit this, so we can see that we have solved this problem successfully now. And if I tell you the time and space complexity, so we can see that we are running this for loop once, and inside this for loop also, from 1 to n, we are erasing the element also, and erase function takes big of n time complexity. So we can say that time complexity overall is coming big of n square, and space complexity we are using for storing the resultant string, this will be big O of n. So this was all about this problem. I hope you understood. Thanks for watching. Till then, keep learning and keep upgrading yourself. See you in the next video.